Hi, my name is Simon Trow, and my research project this year is on the effects of copper nanoparticles on the regeneration of planaria, modeling tissue regeneration on an ACL tear. So, Logan Thomas, J.K. Dobbins, and Robert Woods are current players in the NFL right now. And now, they have all had something happen to them during this current NFL season, and that being that all three of them have torn their ACL. Now, this is major for them because while this ended their NFL season, this also puts their playing careers in jeopardy. This could result in them being cut or them being traded. So there's a lot of concern with whenever a professional sports athlete gets one of these when it gets one of these injuries. Now, these injuries happen in all sports leagues, from the NBA to the NFL to NHL to the MLB. But it's not just professional sports leagues. Um, Athletes all the way from high school to professional sports leagues all experience ACL tears. Speaking of high school, the amount of ACL tears has increased among 14 to 18-year-olds over the last 10 years, showing that there really is a no age range to these injuries. And the amount of ACL tears per year is significant, with, according to BMount, approximately 100 to 2,000 per year. So, and the unfortunate thing about ACL tears is that they have a long recovery process. In fact, recovery can take up to 6 to 9 months, which shows just how slow of a process it takes for ACL tears to recover, and why many NFL players consider their whole season done when they get this injury. So, what is an ACL really? Well, an ACL is short for the anterior cruciate ligament. Basically, it's just a ligament in your knee, and and an ACL tear is when that tissue in that ligament tears. So, as you can see here, this is the front view and the side view of the ACL, and then this picture shows you the broken tissue, showing the ACL tear. So, basically, the way that an ACL is able to repair itself is through the process of tissue respiration. And what tissue respiration does is that it helps to restore that broken tissue until it eventually heals. Now, when I wanted to find something that's able to lower the recovery process of ACL tears. Basically, I thought the amount of time it took, which is 6 to 9 months, was a very long and tedious process, and I wanted to find some sort of like treatment that's able to lower this amount, which led me to copper. Copper itself has become an emerging model of study over the years, as more research has been looked into the medical benefit that it provides. It's been linked to helping maintain the nerves, blood vessels, immune function, but its most interesting medical benefit is its ability in helping to maintain healthier bones. Now, knowing this makes it a possible treatment for ACL tears. So, one of the major things copper is able to do is stimulate tissue growth. So, when body tissue is torn, cells start the process of repairing it. However, there could be times when an ACL struggles to repair its broken tissue, so with surgery having to happen. So, copper is able to prevent this by being able to stimulate cell growth. So, this shows how important copper can be to cell growth and how it's able to stimulate it. And it can help prevent that surgery. And even if that surgery happens, one of the major properties of copper is its antimicrobial properties. And basically, ACL tears are susceptible to all kinds of infections, and that they can range from when the tear happened all the way from getting surgery for it. And what copper is able to do is able to kill those infections during those surgeries. And with this, it ensures that the ACL tear is able to recover in a timely manner without any obstacles blocking its way. Basically, those obstacles being any infections. Furthermore, copper has been shown to multiply cells at a quicker rate. Due to the ACL tear process taking a long 6 to 9 months, then this can help potentially speed up that process. Now, copper can also help to increase the functions of the mitochondria of the cells. The mitochondria is the part of the cell that helps us to produce ATP, which the cell uses to store cellular energy. So basically, an increase in ATP helps cells in performing their function, and that function is being able to repair broken tissue. So copper being able to promote and secure the function of the mitochondria, meaning it helps it helps basically the cells to help lead to tissue respiration, and with that tissue respiration, helping to heal the ACL tear in a more higher timely manner. So when doing this experiment, I decided to use copper nanoparticles, and that's because I wanted to find an easy way to apply this to my model organism, which is planaria. Now, what's distinct about planaria is that it's able to regenerate itself. So, when doing this experiment, I thought if I'm able to cut the planaria and with it regenerating itself, it can help stimulate um, a broken tissue restoring itself through tissue respiration. And this is due to humans and planaria sharing many similar traits in their cells, such as both having neoblasts. Now, so this leads me to my hypothesis and prediction that since copper has been shown to have properties that help to promote small growth, copper can be used as a potential treatment for ACL tears and cause recovery to be faster, and that planaria can be used as a model for cell growth through its regenerative properties and can be exposed to copper through the use of copper nanoparticle powder, which can show copper's effects on regeneration. So, my prediction planaria given larger amounts of copper nanoparticles, the time it takes for them to fully regenerate will be less compared to the regeneration of planaria not given copper nanoparticles. So, this is how I did it. My control group was just planaria cut normally, and then my experimental group was planaria given 0.01 grams of copper nanoparticle powder. The reason why this amount is really small is too much copper is detrimental, but both to both humans and planaria, and especially the planaria, where studies have been done that copper toxicity in the water where the planaria is in is is highly detrimental to them. So I applied to the solution through their egg yolk, which is what the planaria eats. So basically, I just took the copper nanoparticle powder, mixed it up with the egg yolk they eat, and that's how they were able to be exposed to the solution. So basically, my methods, um, I observed them through a microscope, and that's how I got my data. But I unfortunately had to switch it to an iPhone, as it's sort of hard to measure them through a microscope. Also, um, as I mentioned, I applied my copper nanoparticles through my egg yolk, and I cut them using a spatula. Basically, just take the spatula and you slice them into a piece. So this is my how I plan my graphical analysis. So this would be my days. This would be my control group. So how what the length of my coplanaria each day, and then the planaria given 0.01 grams. So these were my results. So looking at the left, that's the control group. Look at the right, it's my 0.01 uh, um, grams of copper nanoparticle powder. And as you can see, the planaria given the 0.01 grams of copper nanoparticles actually showed to grow faster in length compared to the planaria not given copper nanoparticles. And you can see here that this is how the planaria with 0.01 grams looked like initially on the first day it was cut. This is what it looked like after. And this is the one exposed to my solution, showing that, and I also have my standard deviation, which is also decently low, showing that my experiment showed that copper was able to increase the length at which it grew. So knowing this, it shows that copper can be an effective method in trying to increase the speed of regeneration. Knowing this, we could further investigate further methods into looking if copper is able to increase the speed of tissue regeneration. And this is the perfect first step into looking at this. While there were some areas such as scaling issues with the photos or really just time constraints, the evidence still shows that the copper was effective in increasing their length at a faster process compared to the control group. Thank you.